Imagine for a moment that you are standing in the middle of a grocery store. To your left, you see the bakery, rows of golden, crusty breads, soft bagels, and pastries. To your right, the produce section, vibrant apples, dirty potatoes, and fibrous root vegetables. And in the aisle behind you, the shelves are lined with oils, butter, and heavy cream. For the last 50 years, a war has been raging between these three aisles. It is a war of ideology, a war of biochemistry, and most importantly, a war for your metabolic health. On one side, we have the calories are king defenders. They tell you that a calorie is a calorie, whether it comes from a donut or a stalk of broccoli. If you eat less than you burn, you lose weight. Simple physics. On the other side, we have the insulin army. They argue that carbohydrates are the unique villain. They say that eating bread spikes your storage hormone insulin, locking your energy away in fat cells, and that the only true path to salvation is to banish carbohydrates entirely and embrace the high-fat lifestyle. But recently, a third player has entered this battlefield, a quieter, more nuanced voice that suggests we have been asking the wrong question entirely. This voice suggests that the problem isn't the amount of carbohydrates you eat. It isn't even the calories themselves. The problem is the structure of the food. This third theory poses a radical question. What if an apple and a piece of bread, even if they have the exact same number of calories and the exact same grams of sugar, behave completely differently inside your body? Not because of their nutrients, but because of their physical architecture. This is the Cellular Carbohydrate Hypothesis, and until recently, it was just that. A hypothesis. A compelling idea is that our ancestors stayed lean because their carbohydrates were trapped inside intact plant cells, while modern humans get fat because our carbohydrates have been pulverized, milled, and stripped of their cellular prisons. But we didn't have a definitive, high-quality human trial to test this. We didn't have a study that pitted these three philosophies against each other in a rigorous, controlled battleground. Until now. Deep in the clinical archives of Norway at the University of Bergen, a team of researchers launched a study that was designed to settle this debate once and for all. They didn't just want to measure weight on a scale. They wanted to look inside the human body. They wanted to see what happens to the most dangerous fat of all, visceral fat, when you manipulate not just the amount of food, but the very structure of the food itself. This is the story of the CARBFUNC trial. It is a story that challenges the keto zealots, the calorie counters, and the whole food purists all at the same time. And the results? Well, the results are going to surprise almost everyone watching this. Before we dive into the mechanics of this trial, we have to understand the enemy. In this study, the researchers were not primarily concerned with the fat you can pinch. They weren't looking at the subcutaneous fat that sits just under your skin and makes your jeans feel tight. They were hunting a much more insidious predator, visceral adipose tissue, or VAT. Visceral fat is the hidden fat. It wraps itself around your liver, your pancreas, and your intestines deep inside your abdomen. You can't see it, but it is metabolically alive. Unlike the fat on your thighs, which largely just stores energy, visceral fat acts like an aggressive organ. It pumps out inflammatory cytokines, chemical signals that tell your body it is under attack. It floods your liver with fatty acids. It causes insulin resistance. It is the primary driver of type 2 diabetes, heart disease, and metabolic syndrome. A person can look relatively thin on the outside, but be a ticking time bomb on the inside because of high visceral fat. This phenomenon is often called TOFI, thin outside, fat inside. So the University of Bergen researchers asked a critical question. What is the best way to destroy this specific type of fat? Is it by cutting carbs to zero? Is it by eating only whole cellular carbs? Or is it simply by eating less food, regardless of where it comes from? To find the answer, they designed a randomized controlled trial. And unlike many nutritional studies that rely on people vaguely remembering what they ate last week, this study was rigorous. It lasted for 2 years, with the most intense data collection happening in the first 12 months. Now, I need you to lean in for this part, because this is the core scientific concept that makes this study so unique. we need to talk about the cellular carbohydrate hypothesis. This idea was popularized by a researcher named Dr. Ian Spreadbury. His theory is fascinatingly simple. Imagine you are a bacteria living in the human small intestine. You are swimming around, waiting for food to come down from the stomach.
If the human eats a raw apple, the sugar and starch in that apple are locked inside rigid plant cell walls made of fiber. These cell walls are tough. They don't break down easily in the stomach. So, when that apple mash arrives in the small intestine, the sugar is still trapped inside the cells. You, the bacteria in the upper intestine, can't get to it. The food sails right past you, deep into the colon, where the gut microbiome is supposed to be. But now, imagine the human takes that same apple, dries it, grinds it into a fine flour, and bakes it into a muffin. Or imagine they eat white bread or a bagel. In this scenario, the cellular structure has been destroyed by a machine before the food even enters the mouth. This is what we call acellular carbohydrates. The cell walls are gone, the starch and sugar are naked. When this acellular food hits the small intestine, it is an immediate feast. The bacteria in the upper gut go into a feeding frenzy. They multiply rapidly. This bacterial overgrowth in the wrong part of the gut causes inflammation. It damages the gut lining. And according to Spreadbury's hypothesis, this inflammation breaks the signaling between your gut and your brain. Specifically, it breaks your leptin sensitivity. Leptin is the hormone that tells your brain, stop eating, you are full. When you eat acellular refined carbs, the theory goes, you develop inflammation that blinds your brain to leptin. You eat, but you never feel truly full. You stay hungry, you overeat, and you store visceral fat. The CARBFUNC trial was designed to test this exact mechanism.
The researchers recruited nearly 200 men and women. These participants were not just looking to lose a few pounds. They had abdominal obesity. They were the prime candidates for high visceral fat. The researchers divided these people into 3 distinct tribes, and this is where the study design gets brilliant. Tribe number 1, the acellular low-fat group. This group was asked to eat a high-carbohydrate diet. About 45% of their energy came from carbs. But here is the catch. They were instructed to get their carbs from refined sources: wheat flour, breads, pastas, the very foods that the wellness community often demonizes. They were the refined tribe. Tribe number 2, the cellular low-fat group. This group also ate a high-carbohydrate diet, matched exactly to the first group at 45%, but their rule was strict. They could not eat flour. They could not eat bread. Their carbohydrates had to come from intact sources: potatoes, rice, fruits, vegetables, roots. If it had been milled or ground by a machine, they couldn't touch it. They were the whole food tribe. Tribe number 3, the Low-Carb High-Fat group, LCHF. This is your classic keto style group. They slashed their carbohydrates down to about 10% of their energy. They ate high fat, butter, cream, oils, meat. They avoided both the bread and the potatoes. They were the fat burner tribe. Here is the most critical variable, the calories. In many studies, the low-carb group is allowed to eat as much as they want, while the other groups are restricted. This often leads to the low-carb group eating fewer calories naturally, which skews the results. But in CARBFUNC, the researchers tried to level the playing field. All 3 groups were prescribed a calorie-restricted diet. Women aimed for about 2,000 calories and men for about 2,500 calories. They matched the protein intake across all groups. So we have a perfect triangular standoff. First, refined carbs plus low fat. Second, whole carbs plus low fat. Third, low carb plus high fat. They followed these participants for months. They didn't just ask them how they felt. They put them into CT scanners, computed tomography, to take cross-sectional slices of their abdomens. This allowed the scientists to calculate the exact volume of visceral fat in cubic centimeters. They also collected stool samples to analyze their microbiome and blood samples to check their insulin and hunger hormones. The stage was set. The hypothesis was clear. The cellular group should beat the acellular group because of the food structure. The low-carb group could potentially beat everyone because of the insulin suppression. But science, as it often does, had a surprise in store. Let's fast forward to the 6-month and 12-month marks. The data is in. The CT scans have been analyzed. What happened to the visceral fat? If you are a die-hard keto fan or a die-hard whole food plant-based fan, you might want to brace yourself. The researchers found that all three groups lost significant amounts of visceral fat. The refined carb group lost about 14%. The cellular carb group lost about 15%. The low-carb high-fat group lost about 16%. When the statisticians ran the numbers, there was no significant difference between the groups in terms of visceral fat loss. Let that sink in for a second.
The group eating wheat flour and bread lost essentially the same amount of deep, dangerous belly fat as the group eating kale and potatoes and the group eating butter and steak. Why? Because they all adhered to the calorie restriction. This finding strikes a massive blow to the idea that refined carbohydrates magically prevent fat loss, even when calories are controlled. It suggests that when you are in a negative energy balance, when you are eating fewer calories than you burn, your body will burn visceral fat, regardless of whether that energy deficit comes from a bagel or an avocado. So, does this mean the cellular carbohydrate hypothesis is dead? Does it mean nutrition doesn't matter and we should all just count calories? Not quite, because when the researchers looked beyond the visceral fat into the secondary data, a much more complex picture emerged. While the visceral fat loss was similar, the changes in the participants' bodies were not identical. One interesting finding appeared when they measured waist circumference. Now, waist circumference is a combination of visceral fat, deep inside, and subcutaneous fat, under the skin. At the 6-month mark, the low-carb high-fat tribe saw a significantly greater reduction in waist circumference compared to the acellular, refined group. This suggests that while the deep fat responded to calories alone, the total midsection size might respond better to carbohydrate restriction. This is likely due to water weight and glycogen depletion that happens on a low-carb diet, but it's a tangible cosmetic and health benefit that the low-carb group enjoyed. But the most fascinating data came from the bathroom, the stool samples.
Remember the Ian Spreadberry hypothesis? The idea that cellular carbs feed the right bacteria in the colon, while acellular carbs feed the wrong bacteria in the small intestine? The CARBFUNC trial found clear evidence that food quality dictates gut health. The group eating the cellular carbohydrates, the whole foods, fruits, tubers, saw a significant increase in the production of butyrate. Butyrate is a short-chain fatty acid that is essentially a miracle molecule for your gut. It is the preferred fuel source for the cells lining your colon. High butyrate levels are linked to lower inflammation, a stronger gut barrier, preventing leaky gut, and even better brain health. By eating intact cells, this group successfully delivered fiber to their colon, where the bacteria fermented it into medicine for their body. In contrast, look at the low-carb high-fat group. Because they cut out most carbohydrates, including many fiber sources, their production of short-chain fatty acids plummeted. They had significantly lower levels of acetic acid and butyrate compared to the high-carb groups. This poses a serious long-term question for the low-carb community. Yes, they lost weight. Yes, they improved their waistlines, but they were potentially starving their colonic bacteria of the fuel they need to maintain the gut lining. Over a period of years, could this lack of butyrate lead to issues? This study suggests it's a risk factor that needs to be managed, perhaps by supplementing with specific fibers that don't spike blood sugar. Another pillar of the cellular carbohydrate hypothesis was leptin resistance and hunger. The theory stated that refined acellular carbs would make people hungrier and mess up their hormones. The CARBFUNC researchers measured ghrelin, the hunger hormone. If the theory held true, the refined carb group should have had raging ghrelin levels, while the cellular and low-carb groups should have been satisfied and full. But the data showed no significant difference. Fasting ghrelin levels didn't change drastically between the groups. The participants on the refined flour diet were not statistically hungrier than the ones on the whole food diet, provided they stuck to the calorie limits. However, there is a catch here. This was a controlled trial. The participants were given recipes and told what to eat. In the wild, outside of a study, refined carbohydrates are hyper-palatable. They are soft, easy to chew, and hit the dopamine centers of the brain.
So while the hormone ghrelin might not have changed in this controlled setting, the behavioral drive to overeat refined foods in the real world is still a very real factor. So, where does this leave us? We have a study from Norway that seems to contradict the popular wisdom of the last decade. The CARBFUNC trial tells us a story of hierarchy. At the top of the hierarchy is energy balance. If your goal is to reduce visceral adipose tissue, the killer fat that causes diabetes and heart attacks, you must reduce your energy intake. You cannot out-eat your biology. Whether you choose to do that with sourdough bread or with steak and eggs, the energy deficit is the primary driver of visceral fat loss. That is the volume knob of weight loss.
But below that, we have the hierarchy of metabolic quality. This is where the food choices matter. If you choose the low-carb route, you get the benefit of a slimmer waistline faster, and you likely get better blood sugar control, though this study focused on fat mass. But you pay a price in gut microbiome diversity and short-chain fatty acid production. If you choose the cellular carb route, whole foods, you lose the same amount of dangerous fat, but you also feed your gut lining, produce anti-inflammatory butyrate, and maintain a high fiber intake. If you choose the acellular carb route, refined foods, you can still lose the fat, but you miss out on the gut benefits, and in the real world, you are fighting a constant battle against the convenience and addictiveness of ultra-processed foods. The researchers concluded that for visceral fat, a calorie is a calorie, but for health, for the ecosystem living inside your colon, and for the shape of your body, the source of that calorie dictates your biological destiny. Now, responsible science communication requires us to look at the limitations. No study is perfect. First, this study relied on intention-to-treat analysis. This means that if someone was assigned to the low-carb group but cheated and ate pizza, their data was still counted in the low-carb group. This is standard practice in medical trials to mimic real life, but it can dilute the results. It's possible that if the low-carb group had been 100% perfect, their results would have been stronger. Second, the dropout rate. As with all diet studies, people quit. About 30–40% of people didn't make it to the 12-month mark. This tells us something important. Diets are hard. Whether you are asked to cut fats or cut carbs, sticking to a restriction for a whole year is a massive psychological challenge. The best diet ultimately is the one you don't quit. Third, the population. These were Norwegians with abdominal obesity. They were generally healthy aside from their weight. We cannot automatically assume these results apply perfectly to someone with advanced type 2 diabetes or severe metabolic derangement, although the mechanisms of visceral fat loss are likely similar. The CARBFUNC trial provides a refreshing dose of reality in a world of nutritional extremes. It liberates us from the fear that eating a single piece of bread will instantly turn into belly fat. It confirms that the laws of thermodynamics still apply to the human body. But it also warns us that weight loss is not the only metric of success. If you lose 20 pounds of visceral fat but starve your good bacteria, have you truly won? If you eat healthy whole grains but eat so many of them that you remain in a calorie surplus, will you ever lose the dangerous fat? The answer appears to be no. The sweet spot, perhaps the Goldilocks zone suggested by this data, might be a diet that respects the calorie limit necessary for weight loss, but prioritizes the cellular structure of food to maintain the microbiome. It brings us back to the wisdom of our ancestors. They didn't count calories. They didn't track macros. They simply ate food that still looked like life. They ate cells. They ate structures that required chewing and digestion. Maybe the secret isn't just low carb or low fat. Maybe the secret is simply eat cells. As we wait for more long-term data to emerge from studies like this, the actionable advice is clear. If you want to lose the dangerous fat, control your intake. If you want to keep your gut alive, choose the apple over the apple juice. Choose the potato over the potato chip. And respect the biology that has evolved over millions of years to process whole, intact plants and animals, not the dust and powders of the modern industrial machine. This content is for educational purposes only and should not be taken as medical advice. The CARBFUNC trial was a specific research protocol conducted under supervision. Always consult with your doctor or a registered dietitian before making significant changes to your diet, especially if you have metabolic conditions like diabetes. If you find this video interesting, consider like, subscribe, and share. Thank you.